Hello everyone. Today's reading part is Interior of the Earth from Fundamental of Physical Geography, the textbook for class 11. And this chapter shows the nature of the Earth's interior. It is a topic that can only be understood through the indirect evidences, as no one has physically reached it. What do we imagine about the nature of the Earth? Do we imagine it to be a solid ball like cricket ball or a hollow ball with a thick cover of rock that is lithosphere? Have we ever seen photographs or images of a volcanic eruption on the television screen? Can we recollect the emergence of hot molten lava, dust, smoke, fire, and magma flowing out of the volcanic crater? So, as no one has physical reach it, there is no direct evidence, though we have indirect evidence. The Earth's surface configuration is shaped by both internal and external. So, the interior of the Earth can be understood only by the indirect evidences, as neither anyone has nor anyone can reach the interior of the Earth. So the configuration of the surface of the earth is largely a product of process operating in the interior of the earth. We discussed that exogenic as well as endogenetic processes are constantly shaping the landscape. So understanding this process is essential for grasping phenomena like earthquake and tsunamis. A proper understanding of the physiographic character of a region remains incomplete if the effects of endogenetic process are ignored. Human life is largely influenced by the physiography of the region. Therefore, it is necessary that one gets acquainted with the forces that influence landscape development. To understand why the earth shakes or how a tsunami wave is generated, it is necessary that we know certain details of the interior of the earth. In the previous chapter, we have noted that the earth forming materials have been distributed in the forms of layers from the crust to the core. It is interesting to know how scientists have gathered information about these layers and what are the characteristics of each of these layers. This is exactly what this chapter deals with us. So, sources of information about the interior of the earth. Understanding the interior of the earth is challenging because its center is about 6,378 kilometer, and no one can reach it to observe or collect samples. Okay, so you might wonder how scientists can know about the earth's interior and the materials found at such a great depths. Most of our knowledge comes from estimates and inferences, but we also have some direct sources of information. So, the most easily available solid earth material is surface rock or the rocks we get from mining areas. Surface rock and mining. So, the easiest materials to study are the rock found on the earth surface or those obtained from mining. For example, gold mines. For example, we can say gold mines. Okay, gold mines in South Africa go as deep as 3 to 40 kilometers. But going deeper is difficult due to the extreme heat. However, these mines give us valuable insights into the Earth's crust. So another one is we can say deep drilling projects, deep oceanic drilling projects. Okay, so scientists have undertaken projects like the deep ocean drilling projects and the integrated ocean drilling projects to explore the Earth's crust by drilling deep into it. The deepest drill so far at Kola in the Arctic Ocean reached 12 kilometers. These projects provide important information by analyzing materials collected from various depths. Another, volcanic eruption. Another way to learn about the Earth's interior is through volcanic eruptions. When a volcanic eruption uh, occur, molten materials called magma is thrown into the Earth's surface. This material can be analyzed in laboratories to understand more about the Earth's interior. However, it is difficult to determine exactly how deep the magma comes from. There are indirect sources also. So, analysis of properties of matter indirectly provides information about the interior. We know through the mining activity, the temperature and pressure increases with the increasing distance from the surface towards the interior in deeper depths. Moreover, it is also known that the density of the material also increases with depth. It is possible to find the rate of change of these characteristics. Knowing the total thickness of the earth, scientists have estimated the values of temperature, pressure, and the density of materials at different depths. The details of these characteristics with reference to each layer of the interior are discussed later in this chapter. Another source of information are the meteors that at time reach the earth. However, it may be noted that the materials that becomes available for analysis from meteors is not from the interior of the earth. The materials and the structure observed in the meteors are similar to that of the earth. They are solid bodies developed out of materials same as or similar to our planets. Hence, this becomes yet another source of information about the interior of the Earth. The other indirect sources include gravitation, magnetic field, and seismic activity. The gravitation force is not the same at different latitude in the surface. It is greater near the poles and less at the equator. This is because of the distance from the center to the equator being greater than at the poles than that at the poles. The gravity values also differ according to the mass of material. The uneven distribution of mass of material within the Earth influences these values. The reading of the gravity at different places is influenced by many other factors. These readings differ from the expected values, such a difference is called gravity anomaly. Gravity anomalies give us information about the distribution of mass of the material in the crust of the earth. Magnetic surveys also provide information about the distribution of magnetic materials in the crustal portion and thus provide information about the distribution of materials in this part. Seismic activity is one of the most important sources of information about the interior of the earth. Earthquake. This study of seismic waves provides a complete picture of the layered interior. An earthquake, in simple words, is shaking of the earth. It is a natural event. It is caused due to the release of energy which generates waves that travel in all directions. Why does the earth shake? The release of energy occurs along a fault. A fault is a sharp break in the crustal rocks. Rocks along a fault tend to move in opposite direction. As the overlying rock strata press them, the friction locks them together. However, their tendency to move apart at some point of time overcome the friction. As a result, the blocks get deformed As a result, the block get deformed and eventually they side past one another abruptly. This causes a release of energy, and the energy waves travel in all directions. The points where the energy is released is called the focus of an earthquake. Alternatively, it is called the hypocenter. The energy waves traveling in different directions reach the surface. The point on the surface nearest to the focus is called epicenter. It is the first one to experience the waves. It is a point directly above the focus. Earthquake waves. All natural earthquakes takes place in the lithosphere. We will learn about different layers of the earth later in this chapter. It is sufficient to note that here that the lithosphere refers to the portion of depth up to 20 km from the surface of the earth. An instrument called seismograph records the waves reaching the surface. A curve of earthquake waves recorded on the seismograph is given in figure 3.1. This is the curve, that is P wave, S wave, and surface wave. This is arrival times, and this is amplitude. Amplitude. The curve shows the three distinct sections. This is representing different types of wave patterns. Earthquake waves are basically of two types: body waves and surface waves. Body waves are generated due to the release of energy at the focus and move in all directions traveling through the body of the earth, hence the name body waves. The body waves interact with the surface rocks and generate new set of waves called surface waves. These waves moves along the surface. The velocity of waves changes as they travel through materials with different densities. The denser of the materials, the higher is the velocity. Their direction also changes as they reflect or refract when coming across materials with different densities. There are two types of body waves. They are called P waves and S waves. So P and S are body waves. P waves move faster and are the first to arrive at the surface. These are also called primary waves. The P waves are similar to sound waves. They travel through gaseous, liquid, and solid materials. S waves arrive at the surface with some time lag. These are called secondary waves. An important fact about S waves is that they can travel only through the solid materials. These characteristics of S wave is quite important. It is help scientists to understand the structure of the interior of the earth. Refraction causes Reflection causes waves to rebound, whereas refraction makes waves move in different directions. The variation in the direction of waves are inferred with the help of their record on seismograph. The surface waves are the last to report on seismograph. These waves are more destructive. They cause displacement of rocks and hence the collapse of structures occur. Propagation of earthquake waves. Different types of earthquake waves travel in different manners. As they move or propagate, they cause vibration in the body of the rocks through which they pass. P waves vibrates parallel to the direction of the wave. These experts these exerts pressures in the material These exerts pressures on the material in the direction of the propagation. As a result, it creates density differences in the material leading to the stretching and squeezing of the materials. Other three waves vibrate perpendicular to the direction of propagation. The direction of vibration of S waves is perpendicular to the wave directions in the vertical plane. Hence, they create troughs and crests in the material through which they pass. Surface waves are considered to be the most damaging waves. Emergence of shadow zone. Earthquake waves get recorded in seismographs located at far-off locations. However, there exists some specific areas where the waves are not reported. Such zone is called shadow zone. The study of different events really reveals that for each earthquake there exists an altogether different shadow zones. In figure 3.2, this figure shows the shadow zone of P waves and H waves. It was observed that seismographs located at any distance within 105 degree from the epicenter recorded the arrival of both P and S waves. However, the seismographs located beyond 145 degree from epicenters record the arrival of P waves but not that of S waves. Thus, a zone between 105 degree and 145 degree from epicenter was identified as shadow zone for both the types of waves. If you look, that's this 105 degree to 145 degree for P waves, 105 to 145, this P waves, okay, and from 105 to full 105, these S waves are in shadow zone. So the entire zone beyond 105 does not receive S waves. The shadow zone of S waves is much larger than the of P waves. The shadow zone of P waves appears as a band around the Earth between 105 and 145 degree away from the epicenter. The shadow zone of S waves is not only larger in extent but it also a little over 40% of the Earth's surface. We can draw the shadow zone for any earthquake provided by you know the location of the epicenter. Types of earthquake. The most common ones are the tectonic earthquake. These are generated due to the soliding of rocks along the fault plane. A special class of tectonic earthquake is sometimes recognized as volcanic earthquake. However, these are confined to areas of active volcanoes. In the areas of intense mining activity, sometimes the roads of underground mines collapse, causing minor tremors. These are called collapse earthquake. Ground shaking may also occur due to the explosion of chemical or nuclear devices. Such tremors are called explosions earthquakes. The earthquakes that occur in the areas of large reservoirs are referred to as reservoir-induced earthquakes. Measuring earthquakes. The earthquake events are scaled either according to the magnitude or intensity of the shock. The magnitude scale is known as the Richter scale. The magnitude relates to the energy released during the quake. The magnitude is expressed in numbers 0 to 10. The intensity scale is named after Marcelli, an Italian seismologist. The intensity scale takes into account the visible damage caused by the event. The range of intensity scale is from 1 to 12. Effects of earthquake. Earthquake is a natural hazard. The following are the immediate hazardous effects by earthquake. So one is ground shaking, another is differential ground settlement, Third, land and marsh slides. Fourth, soil liquefaction. Fifth, ground lurching. Sixth, avalanches. Seven, ground displacement. Eight, floods from dam and leaf features. Nine, fires. 10, structural collapse. 11, falling objects. 12, tsunami. The first six listed above have some bearing upon landforms. These six up to this. So, while others may be considered the effects causing immediate concern to the life and properties of people in the region, the effect of tsunami would occur only if the epicenter of the tremor is below oceanic waters and the magnitude is sufficiently high. Tsunami are waves generated by the tremors and not an earthquake in itself, though the actual quake activity lasts for a few seconds. Its effects are devastating provided by the magnitude of the quake is more than 5 on the Richter scale. So this is the view of the destruction caused by tidal waves at Marine Beach in India, and this is the view of destruction caused by tidal waves in Thailand. Uh, Here shows the people walk through debris of their houses destroyed by tidal waves on the coastal area in Colombo, Sri Lanka. And this picture shows a view of the destruction caused by tidal waves in Indonesia. Frequency of earthquake occurrences. The earthquake is a natural hazard. If a tremor of high magnitude takes place, it can cause heavy damage to the life and property of people. However, not all the parts of the globe necessarily experience major shocks. We shall be discussing the distribution of earthquakes and volcanoes with some details in the next. This is the picture of view of the damaged Aman Setu at the LOC in Uri due to the earthquake. The quakes of high magnitude, that is 8 plus, are quite rare. They occur once in 1 to 2 years, whereas those of teeny types occur almost every minute. Structure of the earth, the crust. It is the outermost solid part of the earth. It is brittle in nature. The thickness of the crust varies under the oceanic and continental areas. Oceanic crust is thinner as compared to the continental crust. The mean thickness of the oceanic crust is 5 km, whereas that of the continental is around 30 km. The continental crust is thicker in the areas of major mountain system. It is as much as 70 kilometer thick in the Himalayan region. And another is the mantle. The portion of the interior beyond the crust is called the mantle. The mantle extends from Moho's discontinuity to the depth of 2,900 km. The upper portion of the mantle is called asthenosphere. The word astheno means weak. It is considered to be extending up to 400 km. It is the main source of magma that finds its way to the surface during the volcanic eruption. The crust and the uppermost part of the mantle are called lithosphere. Its thickness ranges from 10 to 200 km. The lower mantle extends beyond the asthenosphere. It is an it is in solid state. The core. This figure shows the interior of the earth. This is the asthenosphere, this part is mantle, this part is core, this is the liquid part, and this is the solid part. The core. As indicated earlier, the magnitude waves velocities helped in understanding the existence of the core of the Earth. The core mantle boundary is located at the depth of 2,900 km. The outer core is in liquid state while the inner core is in solid state. The core is made up of very heavy material, mostly constituted by nickel and iron. It is sometimes referred to as the Nephi layer. Volcanoes, volcanoes and volcanic landforms. We may have seen photographs or pictures of volcanoes on a number of occasions. A volcano is a place where gases, ashes, and or molten rock material lava escape to the ground. A volcano is called an active volcano if the materials mentioned are being released or have been released out in the recent past. The layer below the solid crust is mantle. It has a higher density than that of the crust. The mantle contains a weaker zone called asthenosphere. It is from this that the molten rock materials find their way to the surface. The material in the upper mantle portion is called magma. Once it starts moving towards the crust or it reaches the surface, it is referred to as lava. The materials that reaches the ground includes lava flows, pyroclastic debris, volcanic bombs, ash and dust and gases such as nitrogen compounds, sulfur. Volcanoes. Volcanoes are classified on the basis of nature of eruption and form developed at the surface. Major types of volcanoes are as follows, that is shield volcanoes, composite volcanoes, then caldera, flat basalt provinces, and mid-ocean ridge volcanoes. Shield volcanoes, bearing the basalt flows, the shield volcanoes are the largest of all the volcanoes on the earth. The Hawaiian volcanoes are the most famous examples. These volcanoes are mostly made up of basalt, a type of lava that is very fluid when erupted. For this reason, these volcanoes are not steep. They become explosive if somehow water gets into the vent. Otherwise, they are characterized by low explosivity. The upcoming lava moves in the form of fountain and throws out the cone at the top of the vent and develops into cinder cone. Composite volcanoes. These volcanoes are characterized by eruptions of cooler and more viscous lavas than basalt. These volcanoes often result in explosive eruptions. Along with lava, large quantities of pyroclastic material and ashes found their way to the ground. This material accumulates in the vicinity of the vent opening leading to formation of layers, and this makes the mounds appear as composite volcanoes. Then caldera. This is caldera. These are the most explosive of the Earth's volcanoes. They are usually so explosive that when they erupt, they tend to collapse on themselves rather than building any tall structure. The collapsed depressions are called caldera. Their explosiveness indicates that the magma chamber supplying the lava is not only huge but it also in close vicinity. Flat basalt provinces. These volcanoes outpour highly fluid lava that flows for long distances. Some parts of the world are covered by thousands of square kilometers of thick basalt lava flows. There can be series of flows with some flows attaining thickness of more than 50 meters. Individual flows may extend for hundreds of kilometers. The Deccan Traps from India, presently covering most of the Maharashtrian plateau, are a much larger flat basalt provinces. It is believed that initially the trap formations covered a much larger area than the present mid-oceanic ridge volcanoes. These volcanoes occur in the oceanic areas. There is a system of mid-ocean ridges more than 70,000 kilometers long that stretches through all the ocean basins. The central portion of this ridge experiences frequent eruptions. We shall be discussing this in detail in the next chapter. Volcanic landforms. Intrusive forms. The lava that is released during the volcano's eruptions on cooling develops into igneous rocks. The cooling may take place either on reaching the surface or also while the lava is still in the crustal portions. Depending on the location of the cooling of the lava, igneous rocks are classified as volcanic rocks, that is cooling at the surface, and plutonic rocks, that is cooling in the crust. The lava that cools within the crustal portions assumes different forms. These forms are called intrusive forms. Some of the forms are shown in these 3.4 figures. In 3.4 figures, that is composite volcanoes, lava mesa, cylinder cone, okay, lava plateau, ash cone with volcanic dome, volcanic neck, radiating dikes, caldera with cylinder cone on floor, batholiths. A large body of magmatic material that cools in the deeper depth of the crust develops in the form of large domes. They appear on the surface only after the denudational processes remove the overlying material. They cover large areas and at a time assume depth that may be several kilometers. These are granitic bodies. Batholiths are the cooled portion of magma chambers. Laccolith. These are large dome-shaped intrusive bodies with a level base and connected by a pipe-like conduit from below. It resembles the surface volcanic domes of composite volcanoes, only these are located at deeper depths. It can be regarded as the localized surface of lava that finds its way to the surface. The Karnataka plateau is spotted with domal hills of granite rocks. Most of these now exfoliated are examples of laccoliths or batholiths. Lapolith, Phacolith, and shales. As and when the lava moves upward, a portion of the same way may tend to move in a horizontal directions wherever it finds a weak plane. It may get rested in different forms. In case of develops into a saucer shape concave to the sky body, it is called lapolith. A wavy mass of intrusive rocks at times is found at the base of synclines or at the top of anticline in the folded igneous country. Such wavy materials have a definite conduct such such wavy materials have a definite conduit to some beneath in the form of magma chambers that is subsequently develop as batholith. These are called phacolith. The near horizontal bodies of the intrusive igneous rocks are called sill or sheet, depending on the thickness of the material. The thinner ones are called sheets, while the thick horizontal deposits are called shills, dikes. When the lava makes its way through cracks it and the fissures develops in the land, it it solidifies almost perpendicular to the ground. It gets cooled in the same portions to develop a wart-like structure. Such structures are called dikes. These are the most commonly found intrusive forms in the western Maharashtra area. These are considered the feeders for the eruption that led to the development of the Deccan Traps.